Hello, everyone. Hi, and it's a pleasure to meet you at this Milan Video Tech event, which we'll be talking about broadcasting cloud. So thank you for being here. I will give a bit of a run through of the previous events, and we can then go on to today's topic. So the previous meetup was about alternatives in media workflows. It was in the 24-hour video dev meetup marathon, and we talked about how to build different video workflows online and what the different parts are. So for this one, we will be speaking about broadcasting cloud, and we will do it with three industry experts: Brähler from SDVI, Luca Moglia from Akamai Technologies, and Davide Maggioni from Italia. I am Andrea Fassina, and I've been moderating this meetup, in also with Stefano's help. If you have any question after each presentation, then do write them in the chat, and we will direct them to the speaker. So what's the agenda for today? We're gonna have an introduction. Then we're gonna talk about what are the benefits of moving broadcast to play in the cloud. Then we'll have a Q&A for Chris, so feel free to ask questions. Then we're gonna look at 6 ways to bring broadcast KPIs into your cloud by Luca Moglia, and we're gonna have questions for that. After that, we will have a presentation by Davide Maggioni on HD in the cloud, and then we're gonna have Q&A for Davide as well. So with this said, I will pass on the ball to the first speaker, Chris.
Thank you. Hi, everyone. I'm Chris. I'm probably the new guy here. It's the first time I'm attending a Milan Video Tech meetup, and sadly not in person. I usually do fly a lot around the world, so I would love to attend in person, but we can probably do that in future when things go back to a more normal state. So yeah, I'm Chris. I'm the Director of Product Management at SDVI. You can see that the COVID beard has gotten a bit longer from when that picture was taken. Yeah, so who am I and who's SDVI? So SDVI, we are a company that provides a supply chain management platform in the cloud. We help our customers move their supply chain from ingest to distribution into the cloud, and so they can focus on the outcome and not on the infrastructure that is needed. That's all that what SDVI Rally, which is our platform, manages. A bit about me. I've been with SDVI for almost 5 years now. Before that, I spent a lot of time at Omnion, and then we were purchased by Harmonic. So some people might know those companies. So I spent a lot of time in broadcast workflows and in playout workflows. And so yeah, I started as an engineer there, and then moved on to product management after a while at Omnion, and now I'm at product management at SDVI. Oh, so yeah, quick short introduction about myself. So let's jump straight into this. What am I going to talk about today is how our customers basically took these 3 principles of cloud supply chains, which are efficiency, agility, and growth, and applied them to their supply chains, and also what kind of gains they got applying these principles to their supply chains. So we do have a lot of customers across the world. We have a lot of them in America and some in Europe as well, including Sky and Sky Italia. So I'm leaning heavily on their experience here, because obviously I'm from the vendor community, so I have to rely on those. So yeah. So before we get into this in more detail, let's define what we mean when we talk efficiency, agility, and growth. What's efficiency? Efficiency is the ability to increase the output of your supply chain by automating as much as possible, especially repetitive tasks, and then getting the users that you have to apply their value where it's necessary. So not everything is automatable. So sometimes you might need to have a manual task in there, but you want to do also that as efficient as possible. So what do we mean when we talk about agility? Agility basically is how you can adapt to changing environments in our case, obviously the media industry. So that's a new device coming out, a new 8K coming out, 4K coming out, and how quickly you can adapt to these changes and adapt your supply chain and your operations to these changes. So you want to be as agile as possible. And the last one, growth, is probably also pretty straightforward. How can you grow your supply chain and adapt also then to new business requirements or more? Because usually I think most of us here know that we are being asked to do a lot more with less, or at least not more infrastructure. We're just supposed to do more things with the things that we already have. Okay, so that's just to setting the scene what efficiency, agility, and growth is. And now we're going to go into each one of those and talk in more detail on these principles. Yeah, there we go. Cool. So the first one is efficiency. I'm again going to talk about what our customers did and how they applied this principle. So the problem this first customer was facing is that for every hour of content that went on air, they basically had 2 operators watch this content at full length. So basically they had 2 hours of quote unquote human eyes on each hour of content that goes to air. And obviously that doesn't scale very well, right? So if you want to do more content, you have to get a lot more eyes, and it's not the most efficient use of time here, right? So that's the problem. How did they solve this? And there we go with a little diagram here. And that diagram is the supply chain they have built. I'm using some AWS icons here, so we have an idea what we're talking about. Obviously, it would work in every cloud. This specific customer is using AWS. And also these Lambda symbols or half-life symbols, depending on your background, you can substitute them for actually a different kind of decision engine, serverless code execution engine that they were using in this case. But just so it makes sense for everyone. So let's go into a bit more detail on each one of those steps and why they chose them and how also they made their supply chain more efficient. So content arrives, there's a S3 bucket there that shows that content. And the first thing they do is automatically run a media info on the content. And media info actually has an S3 native implementation, which is super efficient because it basically just reads what it needs to read from the file, which is the header. So it's super quick. And also there's like not a lot of data movement needed. So first step, already efficient in itself, because the lovely open source community at Media Info has implemented this S3 native implementation. So how is this Media Info helping them to be more efficient at the start? Because that Media Info gives you information about audio tracks and video tracks and how long the material is and if it's SD or HD. So it already at the beginning can figure out if the clip that I've been arriving is worth going through other supply chain steps that may cost money. So either because they're a transcode or because someone is actually looking at the material or not. So you can then, this decision engine in there in the middle, you can see this Lambda symbol. It will go and check for example, the length of the content. You can see there's another symbol, which is the API gateway, because to realize and to properly verify that the clip is the correct clip that was supposed to come in, this script needs to know what was supposed to come in. So there's a channel planning and a contract system that you can ask for information, or the script can ask for information about what's supposed to come. So simple example, if the clip comes in and it's a 2-minute 30 trailer and the person was supposed to upload the full length video that is 2 hours, right away I know something's wrong here, right? So I can already fail the clip right there without needing any expensive tooling or any person actually looking at the video clip to verify that, and can straight away basically fail that clip and reject that clip. And that instant rejection is also quite nice because that particular customer has a custom front end where their suppliers upload the media. And when they finish the upload, they immediately get the response back if it passed this first check or not, because that would mean, I uploaded the wrong thing, stupid me, let's upload the other thing. So instead of uploading it or even sending it via tape, like in the olden days, and then 2 weeks later, getting a message back, you sent us the wrong thing. You get that immediate, and then you can fix it, and then you can go into your weekend as a supplier. So that's already great efficiency gains in the first step. Then it goes further into the supply chain. You can see there's like a probable path there where it goes through a little transcode. This random icon signifies a transcode which runs on a EC2 instance. And that is if that content is not quite matching the specification this customer wants, but it can be fixed. So let's say they only want MXF file and someone delivers a QuickTime file. Instead of then rejecting it, they can just rewrap it in that step and then go on in the supply chain, because that rewrap is very quick, very cheap, and a lot quicker for them to ask the supplier to redeliver, and that might take another week, and then it might be wrong. So they have a couple of basically things that they are happy to fix, so they fix them when they come up. So that's what this step is. And then you can see things go in parallel, which also is, again, about efficiency. What you can parallelize, you parallelize, and because it's in the cloud, you can just parallelize everything as much as possible, because you just spin up resources when you need them. And in this case, they create actually 2 proxies, one for just for viewing in the web, and the other one for some manual QC work that we'll talk about later. And they also run an automatic QC. Actually, in reality, the supply chain is a bit more sophisticated there. It has a couple of QC tools to choose from, depending on the content. And if one fails, it goes to another one. But not to try to make that image too complicated. We decided to just show that one QC step because it's essentially QC step. These 3 run in parallel, and then there's another decision to be made. So another Lambda-like function runs here that looks at this QC report and basically figures out what went wrong in the QC report, because very often something went wrong. If nothing went wrong, it goes straight into the green happy path and goes into delivery or editing or whatever needs to happen downstream. In many cases, that's not the case. There's something that the QC found that is wrong with the clip. So it goes down to the manual QC path, where there's yet another decision to be made, a decision engine, to run, and another scripting to run, which gets data from the channel planning system to also import segment data and support ad data. So you can visualize the QC errors at the same time as you can visualize the errors that, the segment times at the same time as you can visualize the errors. All of this runs into an Adobe session at this company. There's an Adobe panel that takes all of this data and visualizes on top of the video. So people can see that data there. So that's also where a lot of the efficiency gains come in, and probably almost all of them when it comes to the actual manual QC. Because here, having the automatic data that comes in assist the user with the manual QC here, offers tremendous efficiency gains. Because let's say you have a 2-hour movie, for example, and in the last 15 minutes of the movie, there's like a 10-second stretch where there's no audio, or a 10-second stretch where the video is like completely broken. There's black frames, freeze frames, or there's just flockiness all over the clip. You've all seen these broken videos probably before yourself. So in the quote unquote old world, before there was the supply chain that had some automatic assist QC here, these operators would watch the whole movie. And at the end of the movie, after watching it for 1 hour, 45 minutes, they would get to this broken clip and then realize, oh no, this is broken. We need to have this redelivered. And they might have enjoyed the movie, who knows, but that's not very efficient, right? So you now, with having a panel that allows you to jump straight into the right point in time, the operator opens this, sees there's a problem at the end of the movie, jumps straight there, sees the problem and rejects it straight away. So now the operator spent perhaps like a couple of minutes on the clip instead of almost 2 hours. So that's a tremendous efficiency gain. And also because it's the same operator that verifies segment time, so little black frames to insert the ads, as they do with the QC, the same operator is doing the same job within 5 minutes instead of, again, old world where it was 2 people running this independently from each other, and you ended up with 2 minutes for 1 hour. So that resulted in that this specific customer had an 80% reduction in human involvement for this ingest workflow, 80%, which is ridiculously large. And again, when nobody was there in the business of letting these people go or anything, that was just so these people are more efficient, because now they can run more and more and more content with the same people, and there's less failure rates, because again, the phone might ping because you get a WhatsApp, so you look at it, so right at the moment you get a failure there. If you run this assisted, you have a lot more focused operation there. And then based on this outcome of this QC, the operator fails it or goes, this clip is okay, and it goes on into supply chain. So again, the efficiency gains in the supply chain were at many different spots. The biggest one, obviously, when it comes to the actual menu QC. But even before that, they try to automate as much as possible without even a human looking at this video. For example, seeing that the duration is like way off, or there's no audio whatsoever in the clip. And also not forgetting being able to automatically fix some of these things and have just the cloud infrastructure scale up and down as it's needed for these clips. So yeah, that's the first example how this specific customer got more efficient using the cloud and using automation in the cloud. Next one in line is agility. So again, agility is the way how quickly can you adapt to a change in requirements, a new requirement, or in this case, a nagging issue that you had within your supply chain. So the problem in this case was that this customer had suppliers and many different suppliers sending them clips, and obviously every single one of those suppliers used a slightly different tool to create the video or the program for that customer of ours. And every now and then there was a problem where the clip ran through this rewrap step that you saw earlier, because it was QuickTime, not an MXF, and it came out without any audio. So they're thinking, like, what's wrong? They were looking and figuring out. So the first thing that already was helping them to be more agile was with the cloud, and the cloud being usage-based, you are then able to get a lot more data out of the system. So they were figuring out that the actual problem with all of these clips that had no audio was a specific version of a specific tool these people were using to create those clips. I'm not naming because I don't want to name and shame anyone, but it was like an edit environment or a graphic environment that people were using to render those clips out. And they were writing these QuickTimes in a certain way that their rewrap software was always losing the audio. So they went to the rewrap software vendor and they said, like, okay, we see this, it probably will take us half a year to fix because of our roadmap and so on and so on. So they needed to solve this solution. And the cloud agility came into play here. And the important bit here is that the cloud does not just offer like technical advancement over a more traditional on-premise based approach. So cloud obviously offers scalability. Cloud offers a lot of services out of the box that you can just use and APIs. So that's all fine. And we looked at the benefit of those when we looked at the efficiency. But what we were actually looking at here from an agility is the benefit that the cloud brings based on different business models. So you don't just run what you run on premise and run it in the cloud. That's not cloud, that's just virtualization. What you want to do is also make use of the cloud business model, which is usage-based pricing usually. So you can just use a tool and pay for what you use. You don't have to buy a big farm or something like this. And that's exactly what this comes down to. So surprise, surprise, the customer we're talking about is the same customer. So the supply chain we were talking about is still the same supply chain here, which makes this nice and easy to go through because we don't need to really explain the supply chain anymore. So we just go into, you see it's the same supply chain. I'm basically fading out the right-hand part of this because it's not relevant in this little example here. But because we already had the media info step in there, we could read out what version and what tool was used to create those clips, because media info gives you that information because it's in the file header. So now all they need to do was adapt this little script here to find the clips that were created by this specific tool and version, and then route this to a different transcoder to fix it. Because again, this transcoder they were using to rewrap the clip was losing the audio, so let's use another one. So again, and how is that a cloud benefit? Simply because they were able to use usage-based pricing. They didn't have to buy a transcoder, because again, they have in an old world, you have your transcoding farm and that's what you have to use. And if you need a different transcoder like every other Wednesday, that doesn't really justify you buying another couple of servers and finding a rack and putting them in there and getting a license and installing that on there. You basically have to find another way of doing this because it's not worth the effort. In this case, there is no effort because you can just use a different tool and just pay for what you use. And if in 1 month's time you don't get any of those clips in because there's no new season from these vendors coming in that gives you these weird tools, cool, you don't have to pay anything for this. And if all of a sudden 3 of those suppliers give you like 3 more seasons of a series that they were giving you or supplying to you, all of a sudden you have 75 clips a day you need to run through there. Also fine, it just scales as you need it. And also then in future, perhaps this troubling tool gets an update and you don't need this anymore because they actually write the clips in the correct way. You can just phase this out, or you don't have to phase it out because it doesn't cost you anything to keep that in the supply chain. So that's an example how cloud is not just a difference maker in technology, and it is. I'm not going to want to downplay this. Obviously, it has great technology benefits. It also is a difference maker in business models, and that allows us as engineers to be able to build supply chains and adapt to things a lot quicker, because we don't have to worry about the financial implications so much. We can just build a best of breed solution. The last one with growth. No suspense here. We're going to talk about the same supply chain again because that makes it easy, and the same customer. So that customer merged or purchased a different media organization in the US, and they were roughly the same size. So they were tasked, the engineering team was tasked with figuring out how to get all of this catalog from this other broadcast company into their archive and into their supply chain. And that's, I mean, pretty straightforward where the cloud benefits there are from, right? You can simply take all of this content and run it through your same supply chain because you don't have to worry about, okay, it's the same size, right? I need to find another building with another rack room and put all the stuff that I have in the other rack room in there as well. So I'm able to run this. Or I need to do this over a 3-year period because then I can like fit it in when there's not a lot of stuff going on in my supply chain already. But then there's the marketing department, the test department coming in now. We just paid a lot of money to get this, to buy this other broadcaster. We want to use this material on our channels because otherwise it was a dead investment. So the cloud, again, it's not rocket science. With the scalability here, the cloud enabled tremendous speed, so they were able to run the whole back catalog through in about 2 to 3 months instead of what usually would have been like probably a 2-year process. And they could do that with very limited changes to the supply chain. That basically you could see there's just another bucket showing up because it's a different company, right? And there's a different API gateway showing up because obviously they have a different channel planning system. So all they need to do is take the data from this different system, make it into the correct format that this script can read, and all of a sudden everything else can run the same because they already have fixer steps. They already can rewrap the clips. And if they all of a sudden need to rewrap a lot more clips coming in because they might have had a different house format, not a problem. All of this can just scale up. And the same downstream here. So all of a sudden running twice as much content through as you usually do. All of these services just simply scale up because that's the benefit of the cloud. And that was what I was talking about. And with that, my time is up. And if there's any questions, I'm happy to answer them. And I go back to Andrea.
Yeah, if you guys have any questions, then do please address them to Chris. Thank you so much. Chris for the presentation, and we gather question either now or at the end. And with this, I will pass on to the next speaker, who is Luca Moglia from Akamai. So,
yeah, thank you a lot, Andrea. Thank you, Chris.
Thank you.
Very nice session. So let me present myself. I'm Luca. I'm working at Akamai. Let's say I should be working in Milano, but I'm from Torino, and now with the lockdown, of course, I'm stuck in Torino. I used to work for Delta Trend. I see many known faces here. Thanks for being here. Today, I would like to talk about the 6 ways to bring broadcast KPI into your cloud and edge OTT workflow. So it should be really a list of really 6 topics that I think that they are important to be considered. Let's go on. So let's say I use the broadcast word, because of course we know that the broadcast is very robust. There is a lot of let's say knowledge around the fact that one signal is really transmitted to many receivers. So it's really a distribution technology that is working good. While of course the cloud and OTT workflow, where streaming sits, is mostly working on a one-to-one basis. So of course there is a direct touch point between the clients, players, with an edge server, with the origin. There is a lot of importance of the web. So of course the following presentation, the mean is really to try to bring the broadcast KPI, like the quality of the signal, the stability, the robustness of the signal into the cloud and OTT workflow. So let's move on. Let's say that the first topic that I think it's really important is really to secure all the connection. So here I try to show you a kind of layered approach, starting from the right. So starting from really the data center of a company, where you can have the encoding power, you can have the production studio going to the left, to the cloud, where you can have additional processing power. That is currently the topic of this talk. Then going again on the left, where there is the edge, mainly built for distribution purposes, but where we can have processing as well. And of course, ending with the client, with the players, with all the devices that are consuming a stream. Each of these layer, of course, we need to focus on the connection between each of these. We can call them first mile, middle mile, and last mile. Of course, other colleagues are calling them in a slightly different way, but it's important to focus a little bit on each of these connection. So the first one is really to secure the connection from your data center, from your production studio, from where the camera is, the encoder is, to the cloud. I've listed here, let's say the most important cloud right now, AWS, Azure, and Google. I think that all of them are offering kind of way to direct peering with slightly different names. And of course, this is a good way to have a private connection to make your contribution to the cloud instead of going through internet. And this should enhance your KPI and the stability also of the network. We have also some, let's say, edge platform like Akamai and also others that are offering the possibility to do private peering. So of course, depending on your workflow, you can decide to implement that. Then going on, it's also important to secure the connection between cloud and edge platform. And today we have many, let's say, many edge providers like Akamai, that is also Fastly, and others that are building really PNI, so private network interconnection with Google, Amazon, and Azure, and maybe also other in the future within the list. And really, this is a very good way, again, not to distribute your signal on the public internet, but in a way to secure that piece of connectivity between your origin that maybe it's it would be run in, I don't know, Azure or Google or Amazon, and actually the edge platform. So of course, this is again a good way to enhance your KPI, not going through the public internet. Then the last point is, of course, to try to secure the connection between the edge and the client, the devices. And really here there is internet. As you know, internet is an interconnection of a lot of network made by ISP, internet exchange point, data center. And here, of course, we can rely on CDN. Each CDN has its own KPIs, its own benefits. Of course, I can speak about Akamai, but I don't want to transform this in a sales speech. The other approach is, of course, that you can build your private CDN, where basically you will be in charge also about the peering with the different ISP that you would have. So if your business in a particular territory, in a particular geo, of course, you may also investigate this possibility. Good. So the first one is done. Let's move on. Let's speak about the second one. The second one is really let's say a suggestion about offloading the origin as much as you can. So of course, now when we speak about cloud origin, mainly Google, Amazon, and Azure, of course, as Chris also said, they are very scalable. But of course, you need to manage the scalability. You need to have maybe an orchestration layer to scale your origin if, of course, there is a peak on the client, on the devices, and of course on the edge. And nowadays, of course, let's say the multi-CDN approach is very common. So there might be the possibility that one CDN, the bad performance of one CDN is impacting maybe the other one. So really here, the approach is a kind of additional layer that we can call origin gateway, we can call additional caching layer. We have many ways to call it. That should, let's say, protect really the origin from any spike, maybe even in the CDN request. We can see also this origin gateway concept built in the CDN. For example, Akamai has a product that is called Cloud Wrapper. Fastly is also another product. Many CDN now are starting, and let's say not so many, but some CDN now are starting to offer this kind of technology embedded in the CDN. But I would say that this is a good way really to secure your cloud origin. And the second point is really to try to move the logic to the edge. Let's say that, and I put here as an asterisk also the web function, because of course there are many functions, features that we mostly run on the cloud, like you see manifest personalization, geoservices, images optimization, text compression, security, so really from video, but also to web. And here really, if we move all these services from the edge, of course, we will get more scalability and all these functions will be closer to the user, will be, let's say, with less processing time. Now, many CDN, including also Cloudflare, Akamai, also Limelight, are offering advanced logic with JavaScript on the edge. So again, I would say this is a good way to really move the logic to the edge, closer to the users, have less, let's say, time to process the request, because of course the server will be maybe in the same ISP where the user is connected. So of course we will improve the KPI, and of course we will have a cloud origin that will be offloaded in a more efficient way. Good. Let's move on. The third one is really to trust your KPI and possibly combine them together. So at the bottom, I've put also the third Milan Video Tech meetup that we did really when the pandemic started, or maybe a little bit later. It was April, if I remember well, where we spoke really about KPIs. So we do have, of course, many KPIs, because as you can see here, each piece of the workflow, each box is really containing different function, and I put one single color for each of them, just to have let's say a happy slides, let's say like that. And really the exercise that we can do here is to try to combine them together. For example, I try to list some of the functions that we can combine them together. So we can combine from the encoding process the perceptual quality of a stream with the specific screen size, or also the KPI that we have on the player. This will give us a better visibility about the real KPI. and the real quality experience of the users. Then we can combine, for example, audience KPI with the user habits and maybe with the technical KPI. So maybe we will be able to see if, let's say, some titles that are not getting a lot of views, why it's like that. Is it because they have technical issues, bad quality, the quality of experience is bad? And finally, of course, I think that each company is interested to correlate, let's say, all these kind of KPIs with abandon rate, churn rate, or business KPI. And of course, we can also then start speaking about recommendation engine, personalization, how to, let's say, present the right content to the right user. So of course, this is difficult, I would say, but it opens really a world of customization, and of course, where you can combine KPIs and data, you will discover a lot of behavior and of your users, I would say. Good. So the third is done. Let's move on the third one. Really, the fourth one is to have alternatives or backup, let's say, because of course, really yesterday we have seen that there has been a big outage of AWS, for example, in Virginia, if I remember well. So of course, there are now many companies that are offering a kind of multi-cloud strategy, multi-cloud approach, where maybe you can use a, let's say, container to execute a specific function in a cloud, and maybe to have the an active workflow together with another cloud. For example, I know Harmonic that are using a approach, or also maybe Bitmoving that are using a container approach to run this kind of function. So this is good to be taken into consideration. Of course, we can do the kind of same discussion for the CDN, because of course we can have Akamai CDN 2, CDN 3, also on the CDN part. So of course nowadays multi-CDN is a kind of a standard way to implement a video workflow. But of course here we need to pay attention to the real-time visibility and to the traffic on the origin, because of course having multiple CDN, it may impact really the traffic that the origin has. At the end, we have, of course, we can create a kind of matrix that it's in a kind of way dangerous, because of course, having multiple options, we need that the workflow is still manageable, is still efficient, but maybe we should consider to have really always alternative in video workflows. Then a little bit going on, we can have also alternative on maybe on one box of the workflow that is influencing the other box. The first example, and here at the bottom you can see the links if you would like to have additional information, is really what does it happen if I have an origin failure. So we can implement some logic, for example, on the edge. In this case, I've taken an example from Akamai, because of course I know Akamai, but I'm pretty sure that maybe also other CDN are offering this kind of possibility, where we can first of all detect the origin failure, so the failure detection, and in a second place we can provide action to the edge platform, so to your configuration. If the origin A is down, please go to the origin B. If then the origin A will be up again, go back to origin A. So a kind of logic like that. But of course, it's a good way to have really alternatives also across different cloud, I would say. And then also inside a network, for example, we can have additional logic also to define, let's say, alternative path. Really, these are network path inside a network with, let's say, this behavior that we call a quick retry. And really, by defining different routes, we can really avoid the congestion. And we noted that, for example, customer who implemented quick retry can see a reduction in buffer rates by 50%. So of course, this can really impact in a positive way your KPIs, I would say. Good. So we are at the fifth point, that is really to use the last protocols and techniques. So of course, there are many protocols, there are many techniques. I tried to list a few of them. So of course this list is not the full list. So I encourage you to maybe send to us, write in the chat other, let's say, protocols or technique that you think they're important. So the first one is really to use the last protocol, and one is CMAF, Common Media Application Format. That is a kind of new new application format, a kind of new container for really the video part. So for the chunk of streaming. This is not only to reduce latency, because CMAF has been presented as a nice way to reduce latency, but we have also other benefits. Like the first one is really clear, to improve the cache efficiency between HLS and Dash, because really now we can reference one single chunk, maybe one M4S across HLS and across Dash. So of course, having one single chunk will improve cache efficiency. The cache will be, let's say warmer if compared to before, and therefore we can have a positive impacts on the KPI. Then the second point is that we should have a faster stream startup time, because CMAF basically it's a kind of progressive download, and we don't need to wait that the chunk is totally downloaded to start the playback. So of course, this is another good way to improve it. Similar to the first one, we can have less storage cost. If of course you are doing dynamic packaging on the origin, maybe this is in a kind of way useless, but if you are using a kind of storage, really basic storage to store all your videos, this maybe can be an important point. Then going on, we can have, if we have the same latency of a legacy player, we have an extended buffer on the player, because then now the player will not wait, let's say that the chunk is completely downloaded to start the playback, but it's really that the player can play the chunk while he's downloading it at the same time. So of course we should have an extended, an additional buffer if of course the end-to-end latency is the same. And then finally, we have of course DRM compatibility with chunk. We have the last codec, also the last codec are compatible. So of course it's a future-proof way to transmit the video. Then going on, I took this slide from a post of Willow. You see here that it's really a post of a couple of days ago, if I remember well. Willow is our chief architect, where basically we did a test with a team, Origin in AWS East, and a Chrome browser in San Francisco with Akamai in the middle. And we have seen that, to come back to the first point, that we can improve the cache efficiency, less storage cost. We have seen that really we can referentiate one single chunk of video, both in HLS and in Dash. For example, this is really the same piece of video played back with low latency Dash player, with low latency HLS byte range player. So really a kind of, you know that in low latency HLS, you should divide the chunk in small parts, and you can do that also in byte range. And this is actually the reason of the goal of this post, to show you that this is possible, but also with legacy latency player always in HLS. So really the conclusion here is that you can have increased the cache efficiency, that is important, less storage cost, and of course also interoperability among 4 different type of clients, and I've listed it here. This is really a copy and paste from the blog of Will. So of course, this is a first important point, to use the last protocol, and the first one is CMAF. Then going on, of course, we have a protocol like HTTP2 that it improves basically over a single connection. You can transmit multiple pieces. So maybe the client is opening just one single connection. Over the single connection, I'm transmitting the M308, the playlist, the chunk. So this is improving so the slow start of the TCP connection, because I'm using really one single connection. And then I have also other benefits like multiplexing, server push. On top of that, now it's let's say deployed also HTTP3. That on top of HTTP is increasing the performance, because it's mainly based on UDP. And the main reason is that if a packet gets dropped, that only interrupts that one stream and not all of them. So of course you can have, let's say, improvement of the KPI also using HTTP3. And again, you can rely on your let's say origin if you're not using any CDN, or also on your edge platform if you're using any of them. Good. Let's go on. Here I just did a quick search on Google about BBR and CDN. BBR is an algorithm developed originally by Google that is bottleneck bandwidth and round-trip type congestion control algorithm, and it's really a kind of way to avoid congestion over TCP. The result is that nowadays there are many companies that are supporting these. For example, the second one is Medianova, that is a CDN provider from Turkey, if I remember well. There is Amazon, there is Akamai. So of course, it's important for you to check that CDN or your deployment in your cloud, on your data center, is supporting this type of techniques to improve really the performance. For example, in Akamai, we have seen that between 5–18% of improvements in average throughput across global geographies. So of course, these are important numbers. If you sum this one to maybe the benefit of CMAF, to the benefit of HTTP3, HTTP2, of course, this will impact your KPIs. Then another one is again about one technique that is quite simple, but it's giving you many benefits. That is segment prefetch. So this is really how our stream is working from the device to the CDN or edge platform to the cloud or origin. So you get, first of all, the manifest that if it is not in cache, you will go to the edge and then to the origin. The player get the manifest, and then in the manifest, the player will see all the segments and we start the GET request in order to have the segments. This is the standard way how everything is working, but with segment prefetch, basically we can enhance one hop of the chain, because when the edge platform is receiving the M308, so the manifest from the player, it can start directly to prefetch the next segment of the stream. So basically, as you can see clearly, we avoid one hop going back to the device, then the device will request it back to the edge, but we can directly do that on the edge platform. And then when the device will request that segment, we'll do the get, the physical get of that segment. The edge platform will have that segment already in cache. So of course, the round trip time will be faster. And again, a blog here if you would like to have additional info about that. Good. I'm running a little bit because maybe I'm out of time, but this is the last point. So it's really, this is not really a kind of protocol technique or a kind of way to, a kind of specific way to improve your KPIs, but this is more a kind of framework of continuous optimization. So of course, my advice is really to focus on data, on KPI. There are many tools. There are Conviva, Honest People at Work, Max, so that there are many tools that can track performance on the player side. We have a KPI on the edge platform. We have KPI on the cloud. We have KPI or maybe a perceptual quality that are coming maybe from the encoding process. So really the idea is to combine them all together and then to adopt this kind of iterative optimization framework where you identify the performance optimization. Then you analyze really using a kind of methodology that we call, let's say, quality of performance, really, so the performance of the stream. And then you go on by identifying the success criteria. Then you identify solution, you recommend solution, and then you execute and validate the solution. And this is a kind of loop that you can really that you can really adopt. And of course, we can see also this loop in my final slide that is really a kind of summary of each 5, let's say, suggestion. But really, the last one, the sixth one, is really to make a single suggestion or single topics in this kind of way of continuous optimization, so that basically you never stop by optimizing your workflow, but optimizing your website, by optimizing your cloud setup, your edge setup, and you always try to improve your KPIs and the quality of experience of your users. And with that, Andrea, back to you. Thanks a lot for being here.
Thank you, Luca. Very interesting presentation and really nice division of different parts. So, are there any questions for Luca? If there are, please write them in the chat, and we will address them at the end also with the questions made to Chris. With this, I will go to the next part, which I will leave to Davide Maggioni. So Davide, the floor is yours.
Hi everybody, I'm Davide Maggioni, and I'm working in Sky since 4 years. I lead the engineering developer team of the technology department in Sky, and today I'll show you how we have deployed the HD sport channels that you are currently seeing on Sky Go and Now TV. I can't, okay. So let's start with the aim of the project. The aim of the project was, as I said previously, switch from SD to HD resolution, 19 sports channels on mobile and desktop devices of Now TV and Sky Go. 3 main business key drivers on this project. The first one was obviously improve quality and resilience of our streams. The second one was to maintain under control costs of this solution. And the third one was the timing. In fact, they asked us to move on the HD resolution bitrates in the middle of July. And we streamed the first channel in production at the beginning of September, because our goal was to go in production at the beginning of Serie A. So based on these 3 business drivers, we have made some choice. The first one was to move the encoding, the encryption, and the metadata enrichment in cloud. And this allowed us to not install anything on-prem. So we cut the times on this part. Then in order to maintain under control costs, we have introduced on our workflow the pop-up channel concept. I'll explain later what the pop-up channel is, but basically are channels that turns on and off according to the schedule of the channel itself. And in order to provide the best quality possible and the best resiliency possible, we have configured our encoders in 1+1, and also this point will be explained later. As for all our project, we have used an infrastructure as a code approach, so we haven't done anything using the GUI of the Google platform, of the Google Cloud. In this case, we have used Google. And we also used a declarative approach in order to use our CI and CD pipeline to deploy all the needed configurations. That's the final architecture of our work. This is one channel. As you can see, we have 2 chains. First one is blue and the second one is red. But let's try to explain how we have created all of this stuff. So first of all, as you can see in this picture, we have used what we had on premise. So for example, the input, the signal input of the channels is on-prem, and it's on the top left of this picture, where you can see mezzanine main and mezzanine backup. Instead, on the right, you can see the Google Cloud platform completely empty. So the first step was to create the infrastructure And an operator has launched a Jenkins pipeline with some scripts that has created two environments, as you can see, on two different zones. So on the same region, but on two different zones, this to provide the most possible resilience on this project. And there were exactly the same thing. I mean, the same configuration. Once we had also the environments, then another operator pressed another button and triggered SCL. SCL is a component that we are using on in Sky Italy, service control layer, that handles all the configuration. So all the configuration that we deploy on our pipelines are automatically created. There is nothing done manually. As you can understand, it's better, is the best solution in order to avoid errors during the deploy. So we have deployed the SCL, deployed the channel, all the configuration. And so the chain is now ready to get the stream from the input. So we have the encoder, the DRM, the origin, and the metadata enrichment. Everything is in place. And here happens the magic with the 1+1. 1+1 is a configuration of the encoder that basically permit to two different encoders that are streaming the same channel to align the source. So the video and the audio source are perfectly aligned. This is very useful because at the end, when you have completed your chain and you are able to stream this channel, you are able to switch all the customers from the blue to the red chain without any impact on the client side. So if there is a problem on the blue chain, we can switch the traffic on the red one without any impact on the customer. Cool. So let's talk about the pop-up channels. As I said previously, we took in consideration costs. And for this reason, we have divided the 19 channels into two groups. 11 of them, in fact, had a 24-hour scheduling. Instead, 8 of them were event-based channels. So during all the day, you have a slide. And for example, during the Champions League days or the Serie A days, you have the matches. So we applied this pop-up channels concept that basically turns on and off the channel only when there is a match. This allowed us to cut the cost because we had a lower computational cost and obviously our lower traffic from the cloud to the client. Let's now see how happens a pop-up channel creation. In this case, there is no need to have an operator that clicks buttons, but we have created EMS. That is the bit that you see in green. EMS stands for Event Manager System, that takes the APG scheduling of the channel and is able to understand if a match is starting. If it's starting, then triggers always SCL. And this time SCL configure the encoders and also a streaming probe. We'll see later why the streaming probe is so important. Then the workflow is pretty much the same of the one we have seen previously. We have the 1+1 alignment between the encoders. This is a really important part of all the workflow. Then when everything is ready and we have the stream ready to be consumed by all our clients, then the streaming probe notice that the stream is available and triggers SCL that puts this channel into the channel lineup. So when the channel is ready, the customer can see the channel. And this is why we have introduced the pop-up channel concept. As you can see here, we have a red line that is the one on top. And this is the consumption if we start all the 19 channels, right? Instead, on blue, you can see which is the real consumption that we have. When you see some peak, it's because we have started the pop-up channel and then we have stopped the pop-up channels, yes. So all the blank part that you see between the red line and the blue one is saving, is just saving. That means money. And so this is the solution that we have in place right now in Sky Italy for our sports channel. And this is what you see. You can check by yourself if you have Sky Go and Now TV, that if you check a channel right now, in a pop-up channel right now is in SD. Instead, when you look at a match is in HD. That's all. So we are hiring. So if you liked this presentation, you can contact me and we can try to keep you on board on this adventure. Thank you, Andrea.
Thank you so much. Thank you. If anyone has any questions for Davide, please ask them in the chat. We had a couple of questions from the audience for Chris. So I think you already replied in the chat, but I will just reiterate the question now, and then you can give a reply as well to everyone else who might have not read the chat. So the first question was about what is SDVI supplying here, the lambdas and the flow.
Our platform, the product we provide to this customer in this use case. So Rally is a supply chain management platform. It does have a graphical user interface, and there you configure your supply chain and what you want to do with that supply chain. So basically the customer configured what you saw on the screen, then not that representation. I drew this to have AWS functionality similar to the ones provided there. And then once you've told Rally via the configuration that you want to do a transcode here and a QC here, and if that happens, then do this. You just run the content through, and Rally just takes care of spin them up and down resources where they need it, so the transcoding and the QC. It runs these Lambda-like decision engines, so you can figure out what to do next and read information from a QC report in these Lambdas. We call them evaluates, but it's basically the same thing. And then also Rally offers when I was going on about the different business cases there, you can get all of these tools on a consumption basis through Rally, even the ones that are normally not available on consumption. So if you need another transcoder, you can just use it, and then Rally takes care of the billing for you as well.
Okay, thank you very much for comprehensive response. We have another question for you. Is there a UI for what you showed? So the orchestration part.
Yeah, Rally has a GUI, and both for the configuration of the system, you do that in Rally UI, and then you also monitor the system in the Rally UI. And there's UIs for the operators as well. So if you need to operate the system, and for example, when I was talking about this Premium panel that overlays things on a timeline, that's also part of the Rally platform. So there's a number of UIs that assist customers with configuring, monitoring, and operating the system.
Okay, thank you. Very important to know that as well, so that can be UI driven. So thanks for replying to those questions. We have a couple of questions for Davide, and the first one is, what was the spec of the mezzanine upload stream, and what did you do here in general to limit latency?
So yes, we are using SRT in order to upload the stream from the on-prem to the cloud, and we are using a direct connect or some couple of VPNs altogether in order to have the best resilience on this piece of the chain. And yeah, in order to maintain the latency low, obviously we have done a lot of work on the network side in order to be sure that we can limit as much as possible the latency. In any case, with the 1+1, we are sure that between the encoders we don't have any drift. So we are sure that the main and the backup chains are exactly aligned at the frame level with the video and the audio. So yeah, we have done a great work in order to maintain the latency as low as possible. And then we have provided this feature of the 1+1 in order to be sure that the main and the backup were aligned.
Okay, thank you very much. Another question is, what do you mean with encoder synchronization? I guess you answered it a bit with what you just said now, but
we take two different streams, and I don't know if I can go back. Let me try on this one. So as you can see here, we have the blue and the red mezzanine. So we have two different inputs, and they are feeding two different encoders. The encoders are able to speak one to each other using some APIs, and they are able to read the timing inside the input, and based on these align the video and the audio. Then obviously we have the encoding and the packaging part. So also on the packaging part, we have the same behavior. So they are able to speak one to each other and align the content, the output content, in order to be sure that the chunk that we are creating on the blue line and on the red line are exactly the same and have the same audio. Hope to have answered the question.
Yeah, I think it's interesting to have the parallel running for backup. So are there any more questions from everyone else? If not, I want to thank you, the speakers today, Chris and Luca, and finally Davide. And I want to leave you, first of all, with a big thank you. Also, we will make available the VOD recording of the meetup in the next couple of weeks. And if you haven't yet, do sign up to the Milan Video Tech meetup. So thank you very much for staying here with us, and thank you a lot for the speakers for the interesting presentations and showing us how broadcast in the cloud is being achieved every day. And I want to say goodbye and good night, and I hope to see you everyone soon. Thank you very much.
Thank you, Andrea.
Thank you. Bye. Bye, everyone. Bye-bye.